Action is looking at some displacement chemistry, and this first one has got some useful information in the question. It tells us that the zinc sulfate is colorless, okay, and we should know and remember from lessons that copper sulfate is a blue color, and also that copper is this red-brown metal, okay? So let's use the information to answer the question. So it wants us to describe what we'd see if we add excess zinc to this solution of copper sulfate. So we can see from the question, if we add the zinc to copper sulfate, it reacts and it forms zinc sulfate and the copper. This is colorless. So we would see the blue color starts to disappear and the solution becomes colorless. And we would also see that copper would start to form inside the container. And how would we see that? We see this red-brown solid forming. So for 2 marks, that's what we're going to say. What we'd see happening is we would say that the blue coloured, hang on, I'll spell that correctly for you. The blue coloured solution would become colourless, and then we'd also see a red-brown solid would form as copper is produced. And there's 2 marks for that question, so we're going to get 1 mark here and 1 mark there. Okay, this reaction is described as a redox reaction. Explain in terms of electrons which particles have been oxidized and which have been reduced. This is a tough question. The key to this is, and I've written the equation down here to help us to do this, so I've just copied it from here just so we've got a reference. So when you have metals like the zinc and copper on their own, they're not bonded to anything, they have 0 charge. So they've got a 0 charge. Sulfates are 2- charged. They're a negative ion. And that means that copper is 2+ and zinc is 2+. So if we have a look at what's changed in here, let's work first of all with the copper. So the copper has gone from here, where it's a 2+, to copper with no charge. So let's just write that down. So the Cu2+ has become a copper atom with no charge. So how do I take a positive ion and make it become a neutral atom? I have got to add electrons, and because it's 2+, I've got to add 2 electrons. So in this case, we're adding electrons, and if I write down the word oil rig, this should serve as a way to remember what's going on. This is oxidation is loss of electrons, reduction is gaining electrons. So because the copper ions are gaining electrons, this is example of reduction, and we would say that the copper ions are being reduced. Okay, let's do the same with the zinc. So zinc has gone from 0 charge to 2+. So how do I go from having zinc with no charge to zinc with a 2+ charge? How to make something positive? I take away negatives. The fact it's 2+ means I'm losing 2 negatives. So they go on this side of the equation. And because I've lost electrons, because this was 0 charge and it's lost electrons to make Zn2+, losing electrons is oxidation, because oxidation is loss. So here I'm going to write down that the zinc is oxidized. Okay, so in terms of marks, explain in terms of electrons. So I've done it in an equation. If you weren't using the equation, you would have to say here that the copper ions are being reduced because they're gaining electrons, or you would say the zinc is being oxidized because it has lost electrons. But because I've put this in the equation, I'm going to get the mark there. So 1 mark there and 1 mark there, and then I've identified which of the chemicals are being oxidized or reduced. So I get a second mark in there as well. Let's carry on. So this is a concentration calculation, and to do that we've got the amount, concentration, volume. If I teach you, we know this as a chicken vindaloo to help us remember the order. So a chicken vindaloo, and this question wants us to calculate the number of moles. So the moles is the amount. So if I use the triangle, the amount is concentration times volume. So here we have got C times V. The concentration is 15.95, and we're going to times it by the volume, which is 50, but that's centimeters cubed. So I'm going to divide that by 1,000. Okay, so let's plug this in. 15.95 times by 50, and then we're going to divide the whole thing by 1,000, and that's going to give me 0.798, and that's going to be grams, isn't it? In grams. And then it wants us, the actual number it wants is to work out the number of moles of copper sulfate. Okay, so if we've got that many grams of copper sulfate, let's now convert that to moles. So to do this, we're going to use our Mr. Moles is underneath the mass. And to work out the moles, we're going to do the mass divided by the MR. So here, let's write that down. So we've got the mass divided by the MR. So the mass is this 0.798. And then the MR we're going to have to work out because we're told the atomic masses. So copper sulfate, the formula is here. So we've got copper, which is 63.5, plus sulfur, which is 32. And then we've got 4 lots of oxygen, which is 4 times 16. So let's plug that into my calculator. So we're going to divide it by 63.5 plus 32 plus 4 times 16, and that's giving me an answer of 5 times 10 to the minus 3 moles. Okay, lots of steps to that one, 3 marks. Obviously we're going to get a mark in here for working this out and the final answer here, and then we'll get a mark for working out the grams that were produced there. Okay, another experiment, 0.043 moles of copper sulfate. So here I've got 0.043 of this is used. Calculate the minimum mass of zinc. So I want to know how much zinc that will get. So I'm not interested in that, and I'm not interested in that. Okay, so first thing to do here is that the ratio in this equation, there is 1 of this and there is 1 copper sulfate. So the ratio is 1 to 1. So zinc to copper sulfate is just a 1 to 1 ratio. And that means that if I've got 0.43 moles of this, I'm going to have 0.043 moles of the zinc. So I now know how many moles of zinc I've got. All I need to do is work out the mass. So let's write mass down, just to remind what we're going to do. And we're going to use this triangle again. So the mass is MR times moles. So we've got the MR times by the moles. The MR for zinc, we're told, is 65. And we've just worked out we've got 0.043 moles. So 0.043 times by 65 is going to be 2.795 grams required. Again, marks wise, 2 marks in there. They're going to give you 1 mark for getting that ratio correct, and then 1 mark for your final answer here. One other thing with this question is to check, because here it says give your answer to one decimal place. So we need to change this answer here to give a final answer of 2.8 grams, and that means it's to one decimal place.